Okay, so we're going to be talking about solving logarithms or solving equations using logarithms and exponents as inverses. Now, some inverses you should be fairly familiar with. In this equation, as I try to figure out what x is, I would first add 3 to both sides. So now I've just got 9e to the power of x is equal to 13. I see that I'm multiplying by a 9, so let's go ahead and do that, and let's divide by a 9. So I've got e to the power of x is equal to 13/9. Now, at this point, I want to eliminate that base, the exponent there. So what we're going to do is we're going to use a logarithm as an inverse. So let's first take a few examples of what that might look like. So for example, if I have something like log of base 4 times 4 to the power of 3. Remember what log is asking. Log is basically asking the question of this base to the power of what is the same as this. So 4 to the power of what is equal to 4 to the power of 3? Well, the answer is obvious. It has to be 3. 4 to the power of 3 is what equals 4 to the power of 3. So notice how we can use that. If I had something like log base 5 of 5 to the power of x, well, 5 to the power of what is 5 to the power of x? X's. So coming back down to this question, we've got this e as a base. I really want to try to get that e out of the way. So because it's as a base, I'm going to use log of base e. So notice now I have the question. E to the power of what would equal e to the power of x? Now if I do it to one side, I need to make sure I also do it to the other side. If you haven't encountered log base e yet, it actually has its very own name. E is just a number, kind of like pi, that it's an irrational number that goes on forever. So don't worry too much about e. It's just a number. And log of base e, we can also write this as just ln. It's called the natural log. So I'm going to take that of both sides. Now, the natural log of anything with a base e is going to leave us with x. So x is equal to the natural log of 13/9. Now, this told us we need to round our answers to the nearest 10,000. So what I'm going to do is type that into my calculator. I'm going to be using Desmos. 13/9. So the thousandths place would be right there. So 0.368. 0.368. And we're done. All right, let's look at the next problem. Once again, it's going to start off with fairly familiar things. I just need to try to get that 9 to the power of m alone before I can use a log to eliminate it as a base. So we'll minus an 8 from both sides, which will leave us with the -3 times 9 to the power of m. and we will get negative 97. Okay, next, divide by a negative 3, and we will get 9m is equal to a negative divided by negative will give us a positive, so we'll just say 97 thirds. And now, in order to deal with that 9, what we're going to do to both sides of this is we're going to do a log of base 9 to both sides of this equation. So 9 to the power of what is equal to 9 to the power of m? M is. So m is equal to log of 97 thirds. Okay, so log of base 9 is 1.582. So approximately 1.582. And there we go. In order to get a base here in log, the way that you'll do it, just type the word log, then press shift and the minus key to do an underscore, and then you can type in what the base needs to be. Okay, or you can click up from here. We got functions. And you've got all of these, and there's the log. But even in using that, notice we're going to need to insert that base anyways. All right. We see a plus 4.9, let's minus 4.9 from both sides. We'll get 3 times 15 to the power of 2x is equal to 61 minus 4.9 should be a 56 point, no, sorry, so 56.1. Okay, now we will divide by the 3 so that we can get that base of 15 alone. So now we got 15 to the power of 2x is equal to 56.1 thirds. And now, once again, I'm going to take this and we are going to do a log of both sides. I'm going to make my base of my log match the base of that exponent. So log base 15 of both sides. So now the left-hand side is asking the question, 15 to the power of what? Is 15 to the power of 2x? Well, 2x. So 2x must equal a log of base 15 of 56.1 thirds. At that point, we would divide both sides by 2, and then we'd have x is equal to a log base 15 of 56.1 thirds all over 2. Okay, so then you just type that in. of 56.1. 56.1. 3. All over 2. And when you type it into Desmos, you're going to type it in looking like that. Use the parentheses to make sure that it creates a fraction right there. And we've got 0.541. Okay. All right, and continuing on. Notice each time, a lot of these solving problems, it's steps that you should have been practicing for a good while before now. So adding the 4 to both sides, and I get negative 3.7. N is going to equal negative 38. Now let's get rid of that 2 that's in front. So divide by a negative 2. Going to have 15 to the power of 3.7. N is equal to negative divided by negative will be a positive, and we get 19. All right, so now we've got our base and exponent alone on one side. So now we're ready to do our log. So log of base 15 of both sides. 15 to the power of what is 15 to the power of 3.7n? Just 3.7n. And then that remains log base 15 of 19. Final step, we're going to divide by 3.7. So n is equal to log base 15 of 19 all over 3.7. Now that answer right there is what we call the exact answer. A lot of times when dealing with log, you're going to get an answer that we approximate, just like what we've been doing. I've been simplifying all the decimals that we've gotten. And that leads to an answer that is not exact. It's a rounded answer. And that's also why each time I use my approximate equals. 0.294. But this answer up above, no rounding has occurred, nothing like that. That represents the exact answer. And so currently, these problems are asking for you to round to the nearest 10,000th. If a question asks you to give the exact answer, you just don't do this last step of simplifying it out. Okay, you just give the answer above. All right, let's do 2 more where we use log to solve it. Let's add the 6. Now notice this right over here. We got a big old exponent. We got a full expression for that exponent, and that is perfectly fine. 65.7. Okay, so as long as the base and the exponent are the same thing or alone, then that works. I'm actually going to do one little extra thing here before we go next. Notice that my base is negative, so I'm just going to go ahead and multiply both sides by a -1, which will get rid of those negatives for us. All the numbers stay the same, but we get rid of the negatives. So multiply both sides by a -1. Now, let's go ahead and focus in on doing our log. So log base 7, log base 7. So we're going to have 8.3 minus 4x is now equal to the log base 7 of 65.7. Let's try and get x alone now, so let's minus the 8.3 from both sides. So now negative 4x is equal to log base 7, 65.7 minus 8.3. Final step, and we'll get that x completely alone. Divide by a -4. Now we've got a pretty long statement there. I'm not going to write it all again, but that statement just above, that would be our exact answer. And then typing it into our calculator, so log of base 7, 65.7 minus 8.3, and all of that divided by -4. So x is going to equal a 1.537. All right, -7 from both sides. We're left with -9. -3 times 9 to the power of -8r minus 8 is equal to -83. Divide by -3. And now we've got our base and exponent alone. So now we're ready to use log. So log of base 9, log of base 9. So -8r minus 8 is equal to a log base 9 of 83/3. Add the 8. -8r is equal to log base 9, 83/3, plus 8. Final step, divide both sides of that by -8, and we're going to have r is equal to a log of base 9 of 83/3 plus an 8 all over -8. Okay, and that's going, so r is going to equal -0.203. All right, so that was us using logarithms to help us get the variable outside of an exponent. But what if our exponent is inside of a log? And especially when we've got multiple logs. So in this first one, I need to use my log properties. I see two different logs that are being added together. So I'm going to use the log property, the product property. So we got log of base 8, and the product property says I can multiply the two of those together in a single log. Okay, so now we're going to have negative 35x. All right, so now in order to deal with the log of base 8, now if this were an 8 to the power of x, we would use log base 8 to get rid of that. And a power of 8 is once again going to be its inverses. Inverses work both ways. In order to undo a +3, we use a -3. In order to undo a -3, you will use a +3. And the same thing works here. So that 8 to the power of log 8 is going to eliminate that. And we're going to be left with 35x is equal to 8 to the power of 2, which would equal 64. So x equals 64, well, I should say negative 64/35 after we divide both sides by that negative 35. Okay, once again, I see that plus there. We're going to use the product property. So log base 7 of x minus 6, and that is being multiplied by 10. And that should equal a log base 7 of 17. Okay, so we can do this. Log, now it'll be 10x minus 60 is equal to a log base 7 of 17. So now because it's a log base 7 for both of those, we are going to use 7 to the power of both sides. So I'm writing my 7 down and to the left a bit to say that everything that is up here is now the power, is now the exponent of that 7. But when you have 7 to the power of log 7, whatever was inside is all that is going to be left. So we're just left with 10x minus 60 is equal to 17. So let's add the 60 to both sides. So 10x equals 77. Divide both sides by a 10. And we will get x is equal to a 77 over 10, or 7.7. All right, this time we see a minus, so it's going to have to be the quotient property. So log of base 8, we've got x minus 3 on the top, x minus 6 on the bottom. So now we've combined our logs into 1. And now we can use our inverse. So we're going to have 8 to the power of all of that, and 8 to the power of 1. So then we'll have x minus 3 all over x minus 6 is equal to 8. All right, well, I've got a bit of a problem. I've got that the x is in a fraction. Okay, this should be easy enough to deal with, though. So the opposite of dividing by anything is just multiplying by that. So I'm going to multiply both sides by an x minus 6. That way this essentially becomes x minus 6 over x minus 6 is equal to 1. And then 1 times the x minus 3 is just x minus 3. We get 8x minus 48. All right, I've got x on both sides. Let's eliminate it from one side. So we've only got an x on one side. So we have 7x minus 48. Let's move that 48 over. So 7x is going to equal 45. Divide by 7. Divide by 7. X equals 45 sevenths. All right, once again, plus, so this is going to be multiplying. Now I'm just going to go ahead and do that quickly. We know we're going to be multiplying by an 8, so the 8 times the negative 3 be negative 24x. The 8 times that negative 6, negative 48. And we've got our one statement. Can't forget the 9 there. Okay, so because it's a log base 9, you can use 9 as the base of the exponent of both sides. So then we're just left with a negative 24x minus 48 is equal to a 9 to the power of 2, so 81. Add our 48 to both sides. It's equal to 129. Divide by the negative 24. And x is equal to 129 24ths. And let's not forget that needs to be negative. Okay, I know that was a long one, but I hope I provided enough examples to help get you through the assignment. Good luck.